So before I get started, I want to let you know that all of the slides and the little bit of code we'll go through today are available at this bit.ly link. And that link is going to persist at the top right corner of the slides today. So you do not need to download it right away, but whenever it's convenient for you, it will be there waiting for you. And what you'll have is a PDF of what we're going over, which can save you some time if you're planning to take notes or whatnot. As Roger said, this is going to be the first in a three-part series about how to build Shiny apps. Originally, we were going to do it all at once, but it quickly became apparent that it'd be much more helpful if we split it up and spend a little more time on each of the subjects. What you're going to learn today is how to build a basic Shiny app. You'll learn to make the parts of the app reactive, and you'll also learn how to deploy and share your app afterwards. Leaving here today, you'll be a beginning Shiny developer. You could make your own apps, but the apps, to be honest, they won't be very thrilling. They won't look that pretty. And even though they do incredibly useful things, what they do in terms of Shiny will be fairly simple. If you come back and join me next week on May 27th, it's a week from today at the same time, we'll look at how to customize the reactions in your apps. So we'll build upon what we learned today, and you'll learn some patterns for making useful interactions for your users to use, such as delaying reactions using buttons, that sort of thing. A week after that, we'll come back and look at the appearance of your app, how to lay out the elements of your app, and how to shape the way they look. This is purely cosmetic, but it's the sort of things that make your app look truly attractive. I'm going to assume that everyone here has seen a Shiny app or knows what a Shiny app is. We will look at some, but the apps we're going to look at today are very simple. If you want a better idea of what Shiny can do, I recommend that you visit this website, the Shiny Showcase. Here I've put together a variety of apps that have been contributed by people who work in different industries, different businesses. This will demonstrate what other people are using Shiny to do. And many of these apps are quite impressive, and they could be a good source of motivation as well as ideas. The other prerequisite or background knowledge I'm going to assume you have is that you know how to use the R language. So a Shiny app is basically a delivery vehicle for an R script. You write an R script, which is a program written with R that does some certain thing. And all the Shiny app does is allow you to make the function of that script available to people who don't know R. You could put it in your app, you could put the app online. People could do the analysis that your R script does without needing to write anything, without needing to do anything really other than click a website. But for you as the developer to make this app, you will need to know how to write the R scripts you have in mind. Obviously, we're not going to learn how to use R in the next 40 minutes, but I'll give you some resources for that. Our studio has actually done a lot of work to make it easier to use R. We've written some books that can get you started. We've made some videos in collaboration with O'Reilly if you prefer to learn through videos. And we've also helped make some interactive tutorials if that's how you prefer to learn through DataCamp. Then at the bottom of this web page here, the bottom of the slide is a web page where I've put together tips that I think would be helpful for someone who's willing to use the internet to learn how to use R with free resources. You'll just have to do a little more work since all these things that I've put together here at this website are free. They're not as polished as the other materials. But if you need to brush up on R, you can start with any of these resources. Let's assume that you know R, and now you want to build Shiny apps. The first thing that I recommend you do is understand the architecture of a Shiny app. And to do that, we'll look at a real Shiny app. So if I leave the slides for a second, come over here. This is a Shiny app. It's a fairly simple app. You may have seen it before. It's an oldie, but a goodie. And what you'll notice is this app is a web page. So this is just Google Chrome that I have open here. Inside the app, there are components built with R. So this plot over here is made with R by calling the plot command. The plot shows data that comes from R. It's the iris dataset, canonical dataset for doing cluster algorithms. And the data in this plot is colored based on a k-means clustering algorithm that R itself implemented. You'll also notice that parts of this website are manipulable. I could open up drop-down menus over here to select different variables to plot, and when I do, the app automatically gives me a new plot generated with R that shows the new variables I selected. And I could also use this numeric input to change the number of clusters I want the k-means algorithm to find. Behind this web page, there's a computer serving the web page. And this computer is running R, has an open R session, and it's just waiting for me to interact with the app. Whenever I make some change to the app, the computer reruns some R code to build a new plot, and it sends the plot to the web page. So think of this web page as the tip of the iceberg. Behind this web page, there's another component to the Shiny app that I can't see, and that's a computer running an R script that the Shiny developer wrote. To put this visually, every Shiny app looks like this. There's a web page that the user visits, and there's a computer that serves that web page by running R. Today, the computer that's serving my Shiny apps is just my laptop. And when you make a Shiny app on your computer, it's just going to be your computer that serves the Shiny app. You might see the Shiny app in your web browser, but it's not coming there from the internet. It's just coming straight from your computer. If you wanted to share the app over the cloud, all you have to do is arrange to have some type of web server service the app. So you set up the web server to run R, to maintain the app, and then anyone can access the app through the cloud because the web server is already designed to talk to the cloud. So what does this mean for you as a Shiny developer? Well, when you make a Shiny app, you'll need to make two components for each app. First, you'll need to make some sort of user interface. This will be a web page that the people who visit your app will see. The user interface will really just be a web document written in HTML, but you don't need to know any HTML. We're going to generate that document from R. The second component of your app will be a set of instructions written in R for the server to follow. These instructions will tell the server what to do when your user changes the different input objects in the app. The instructions will leave the server in such a place that it can handle everything that might happen, and you can go away. You don't have to watch as people use your app. If we take a look at our app, this app over here, I can show you the R code I used to make it. It's all right here. If you downloaded that bit.ly link before and unzip the file, you'll notice that you have these files in your folder. First is the slides for today, and the second says code. And this app is just the code that appears here in app.r. I have it open right here. You'll see that the code has a UI component. All this being saved to UI is building that web document that the app lives in. If I copy this and paste it into the command line, hit enter, you'll see that all it's generating is a bunch of HTML. This is the HTML web page that the R components of our app will live in. Let's go back to our code over here. Next, you'll see it defines a function for the server. This function contains the instructions that the app needed to build that plot and do the clustering. And then finally, this code over here knits the UI component and the server component together using Shiny app. Now that you know the architecture of a Shiny app, it's time to start building Shiny apps. And when you do this, I recommend that you start every Shiny app, whether it's your first or your 100th, with the same template. Use this template until you have a reason not to. This is what the template looks like. It's 3 lines of code if you don't count library Shiny. First line of code sets up a UI object, the second a server object, and the last one's knit the two together into a Shiny app. You can memorize this code. I think you'll end up memorizing it anyways through repetition as you build apps. But for today, you don't have to. I've included it in the code I sent you. It is the o1 template.r file. And if we open that file, you see those lines of code there. To use this template to make an app, all you have to do is copy it and paste it into the command line. When you hit enter, RStudio will launch an app. This is the Shiny app the template makes. It's an empty Shiny app, just a blank page. It's really pretty simple, but it's also very profound. There's nothing in this app, including error messages. So we know that the template works, and it's a safe foundation to build your app into. You could use the template to add things to your app. So you start with the template. If you want to add something to your app, the way you do that is you just add it inside a fluid page in the template. So we could put a piece of text into our app. Copy that to run in a second. Go down here. We'll notice that we don't have a command line to run anything in. And this is just an important little tangent about Shiny apps. Remember, there's a computer that's maintaining the app in the background. And today that computer is going to be your computer. And that computer is using an R session to maintain the app. And today that R session is going to be your R session. So we notice this app is still up. It's just a blank app. And while it's up, our R session is going to be busy maintaining that web page. If we want to do something else in R, we'll have to close the app by clicking the stop button right here. When I click stop, we'll see that the app went gray. That means it's dead, basically. Now I have the command line. So now I'm going to copy and paste the template with my hello world in it. Run that, launches a new app, and you see that it put hello world into our app. Well, obviously we want to put more in hello world in our app, so let's take a look at how we should go about building out our app. Seen the stop signs that stop our apps, and this is the code I just ran. As you build your Shiny apps, I urge you to think in terms of inputs and outputs. Inputs are things that your user can toggle or use to provide values to your app. In our app, we have 3 inputs, 3 drop-down menus that the user can use to select variables and the number of clusters. And then outputs would be the R objects that your user sees. These could be plots, tables, text. They're the things that will respond when your user changes an input. And the way you add them to your app is very simple. In both cases, you just add inputs and outputs to the fluid page section of the template. Anything you put inside fluid page is going to end up in your app, and inputs and outputs are the things we want to end up in our app. You add inputs with input functions, and you add outputs with output functions. So it's fairly simple. All the things we're going to go over today, by the way, are just the ground rules for using Shiny. When it comes to Shiny, I think these are probably the most ephemeral part of learning Shiny, because this is the part of Shiny this is just the way it is. After today, the things we learn will make more sense because they're built upon other things, but for the moment, this is just the way it is. Let's look at how to add input functions. What you see up here is an input function that would build a slider object in Shiny. If you ran this code at the command line, this is what you'd see back, a piece of HTML that's associated with some CSS classes. And when you put this into your template, this is what it adds to your Shiny web page. So if you take your template and you add the slider input function to fluid page, it will build the app you see over here on the right. Now this is just a slide, so I can't actually move that slider for you, but if I ran this in R and launched the app, you'd see that you can manipulate that slider and change its value. Altogether, Shiny provides about a dozen input functions that you could use in your apps. These all come with this Shiny library, and you'll see that most of them end with the word input, which is why I call them input functions. Among these functions, you have options to place buttons in your app, checkboxes, radio buttons, drop-down menus, sliders, and then specialized fields for dates, date ranges, numbers, passwords, and text. All in all, basically every sort of interaction that a user can make with a mouse click on a web page is included in one of these inputs. Each of the input functions take the same basic syntax. They all begin by taking an argument called input ID. That argument allows you to assign a name to the input. You can give the input any name you want, but every input in your app should have its own unique name because you'll use it later to identify the input. One thing to notice is that this argument name has a lowercase d on the end, which can be a bit tricky at first. The second argument that every input function takes is a label argument. When users see your input object like a slider or a button, they won't necessarily know what the slider controls or what to do with it. So a label provides a way for you to explain that. The labels will appear in an intelligent place near the input object. For a slider object, it'll be right above the slider. If you don't want to include a label with your input, just put 2 quotation marks. That'd be an empty character string. And then finally, each input object takes additional arguments that help that input object do its job. For example, a slider input object needs to know a minimum value, a maximum value, and a starting value for the slider, but that doesn't make sense for action buttons and so on. If you want to know what specific arguments to use with a specific input object, you could just look at the help page for that input object. The way you find a help page in R is by typing question mark in front of the name of the function you want to look up. So question mark slider input would open the help page for slider input. And that would explain all the different options for arguments you could pass to slider input. Now let's look at outputs. These are things like plots, tables, text, the things you make with R. Shiny provides a second family of functions, which I call output functions because they all end in output, that place into your app different types of output. So there's a dedicated output function that places plots in your app, a dedicated function that places tables, one that places text, and so on. Here's the complete list of output functions. The syntax for the output functions is somewhat similar to input functions. First, you'll notice at the beginning of the function name for output is the type of output you actually want to place into your app. And then each output function takes one argument, one required argument called output ID. And just like with input functions, this is a name to use for the output. You could pass any name you want here, but again, I would recommend that each output object has its own unique name to avoid errors. So if we add an output function to our app, we pass it to fluid page as a second argument. Don't forget to put a comma between the arguments of fluid page. And then when we run this app in R, this is what we'll see. So it doesn't look very different, which might be a little disappointing at first, but if we looked at the HTML behind this app here, you'd see that there's actually an HTML div put in at this point that sets aside some space for a plot to appear in our app. Now, based on the code we've written over here on the left, the app has no idea what sort of plot to put there. All we've done is tell the app we want the name of the plot to be hist, but we haven't explained, do we want it to be a histogram, which I do, a scatter plot, a bar chart. The app doesn't know anything about what sort of plot to put there, so all it could do is reserve some space for it. Now we need to tell the app how to build that plot, and that's something we do with the server function. But before we look at the server function, let's just recap what we've gone over so far. I recommend that you begin each app with the same template, the template we saw there. You may have seen Shiny apps that don't quite look like that, and I'll talk about that by the end of the slideshow today. But for now, start each app with that template. Second, add elements to your app by passing them as arguments to the fluid page function. Third, create reactive inputs with an input function. And fourth, create reactive outputs with an output function. And then finally, we're going to use the server function to assemble inputs into outputs. So let's take a look at that. The second thing you have to do when you start building Shiny apps is explain to the server how to assemble your inputs into your outputs. This is what the server function looks like in the template. There's nothing in it at the moment. Inside the server function is where we're going to write our instructions for building the outputs that we see. To use the server function, you need to follow 3 rules. And these are the rules. First, if you're building an output object, you need to save that output object to output $. So this is going to save, for example, an object to the hist element of the output list. An output here is just the second argument of the server function output. Both input and output must appear in your server function as arguments, and they're both going to be list-like objects. So here we're just adding an element to the output list of hist. I'm choosing the name hist because this element is going to be the element that gets placed in the plot named hist. So you use the same name in both files, or in both objects. In the server function, the name is an element of the list, and in the UI object, it's a character string inside of the plot output function. The second rule for using the server function is what you save into output should be something built with a render function. So Shiny provides a third family of functions, and these are render functions. And the render functions work together with the output functions to place an R object as HTML into your Shiny web page. You'll see that just like the output functions, there are different render functions for rendering different types of output. For example, we have render plot, render table, render text. In many cases, there's a direct analog between a render function and an output function, like render plot and plot output. What I would like to do for now in our sample app is to just plot a histogram of 100 random normal values. So rnorm100 is how you make 100 random normal values in R, and hist is how you plot some data. So hist rnorm100 would plot a histogram of 100 random normal values. I'm going to use render plot to do it. Let's look at the syntax of render plot. You'll notice that all the render functions begin with render, and then the second argument is the type of object to actually build. In camel case. In this case, I'm going to build a plot. A histogram is a type of plot. The next argument of the render functions is a code block of R code that builds the object you want to make. So we know this code here will build us a histogram to render as a HTML object in our Shiny graph. I'm putting braces around the code to pass it as a unified code block. What the braces let me do is put as many lines of R code as I want into the same code block to pass to render plot. So for example, I could build my histogram like this. I call render plot. I have the braces. I have one line of code in there. Or I could take my time and develop this plot a little more fully. Now I'm using 2 lines of code. First, I'm writing a title, then I'm adding the title to the histogram. And the braces will group those 2 lines together and pass them as a single chunk to render plot to build the histogram. You could put 100 lines of code between the braces. You could put an entire R script between the braces. And this is how you could start building really sophisticated outputs with multiple lines of code going into their making. Just surround everything with braces and pass it to render plot. So that was the second rule. There's just one rule left to create objects for Shiny, reactive objects no less. And that rule is to use input values when you make your outputs. And you could access input values with a syntax similar to the output syntax. So what I mean by input values are the values of the drop-down menus, sliders, action buttons that you put into your Shiny app. Recall that we made a slider input in our app and we gave it the name num. Well, inside of our server function, the value of that slider will be accessible with the syntax input $num. If I had thrown in a second slider and gave it the name num2, then I could access its value with input $num2, and so on. These values of the input functions are special because they always show the current value of the input. So when that slider is set at 25, the current value of input $num will be 25. But when the user moves the slider to 50, then the value of input num will change to 50. And if the user moved it to 75, the value would change again to 75. So when you look up input $num, it'll always show you the current value of the input as set by your user. If you want your output to depend on these values, just use the values inside of the render function when you create the output. So here, instead of making a histogram of 100 random normal values, I'm going to make a histogram of n random normal values, where n is a number set by the user with the slider. Sometimes it might be 25 values, sometimes it might be 100 values. It's up to the user. If you follow these 3 rules, you save your output to an output object, you use a render function to make the output, and you have the output depend on input values, then reactivity will take care of itself. Shiny will handle that for you. Whenever input $num changes, the output saved as hist will immediately update to reflect the change. This is what it would look like graphically. We have our app on the side here. The first time we launch the app, Shiny runs the code inside of render plot. The code is hist rnorm input $num. You'll notice as part of running that code, it's going to access input $num and needs to look up that value. And when it does, Shiny's going to build a connection between this plot and that value input $num. And it'll keep track of the fact that the 2 are related. If a user comes along and changes the slider, for example, they move the slider from 27 to 25, well then the value of input $num will be different. When this happens, Shiny will look at all the things connected to that value, all the things that rely on the value, which includes render plot, and it will notify them that they're now out of date. When render plot knows it's out of date, it automatically reruns its code to make an up-to-date graph. In the process, it looks up the new value of input $num when that code calls input $num. It gets that value, which is 25, and it uses that value to make a new plot. And then the cycle is ready to begin again. This is going to happen so fast that to your users go appear instantaneous. And now whenever they change the slider, the plot will update as well. And that's called reactivity. So let's pause for a moment and just recap what we learned about the server function. You use the server function to assemble your input values into outputs. And when you do this, you should always follow the same 3 rules. First, save the output that you want to build to the output list. If you do that, the output will be accessible by the UI object when you call plot output or text output or whatnot. Second, build the output objects with the render function. The render function helps assemble them into HTML for their final appearance, and it also keeps track of the reactions and the reactivity. And third, access input values with input $ syntax and use them inside the code that you pass to render plot. If you do all 3 of these things, Shiny will make sure the reactivity works for you. The reactivity, in other words, will take care of itself as long as you follow those 3 rules. All right. Now you know how to build your own Shiny apps. And soon we'll look at sharing your Shiny apps. Before we do, let's Let's go back one more time to RStudio. Stop the live app here. And what I want to say is that the last piece of code that I've included with the slides is O2 Hist app. And this is the actual app that we just talked about in the slides. If you run this code in the command line, hit enter, it will launch the app we've been looking at. I can make it skinnier so it looks more like the slides. And you'll see that whenever I change the slider, the histogram adjusts. Sometimes the histogram shows almost 100 different observations in the format that a histogram does. And then I can also make it show just, a couple observations, one observation. So there's our reactive Shiny app. Go back to the slides. So when it comes to making Shiny apps, that's as simple as it gets. You could use those things and make your own apps. And depending on the R code you use, your apps can do all sorts of different things. Now, there are definitely beginner level apps, and in the next 2 weeks, we'll look at how to expand them into more advanced, sophisticated apps. But before we do that, I want to cover how to share your apps, because this is one of the most essential parts of a Shiny app. We make Shiny apps to share them with others or with ourselves, and it's no coincidence that Shiny apps are fundamentally a web page. This allows us to share them over the web. To share your app over the web, all you have to do is arrange to replace your own computer, which shares your app locally, with a web server that can share your app over the cloud. In the very beginning, I suggest that you do this. Well, let me refrain from my suggestions and say, no matter how you arrange to put your app on a server, you will need to save it in a standardized way. Every web server that can handle Shiny apps will expect your app to come packaged like this. You should put your app in any file that the app relies upon, like an image or some CSS style sheets, helper scripts, other R sources. Put them all in the same directory. And then your script that began with the template and ends with the call to Shiny app, save that as a standalone R script in your directory that has the name app.r. You need to use this name. The Shiny server will look in the directory for a script called app.r, and when it finds it, it will use that script to build your app. So remember that name and use it. Now, in the beginning, it was not possible to build a single file Shiny app like we've been doing today. In the very beginning of Shiny, every Shiny app was 2 separate files, a file for the UI and a file for the server. And this format still works, and it's still very useful on certain occasions. The relationship between a 2-file Shiny app and a single file Shiny app is very straightforward. In the 2-file structure, you take everything that you would save to the UI object, and you just put it in a standalone script. You don't need to save it to UI. You just put it in its own script, and you name that script UI.r. And then everything that you would save to the server object, you put that in its own script, and you save that script as server.r. And with these 2 scripts, neither of them calls Shiny app. You don't need to call Shiny app in this scenario. If you have a very, very large app, each of your UI and server objects takes hundreds of lines of code, it can be very beneficial to split your app up into 2 separate files like this. If you do it, this will still work. This technology still works with Shiny, and it always will. If you're building your apps in this way, then when you save your apps, instead of saving a file named app.r, save your 2 files as server.r and UI.r. Again, you need to use these names. Shiny servers will first look for app.r. If they don't find a file called app.r, then they'll look for a pair of files with the names server.r and UI.r. Okay, now you should be able to package your Shiny app into a directory to give to a server. You'll notice that packaging your apps in this way has some other benefits as well. If you save your app files as UI.r, server.r, or app.r, then RStudio will recognize that these files contain components of a Shiny app, and it'll add a Run App button to the top of the page that displays the script. You could click that Run App button to launch your app. So instead of typing in the command line, you could just click the button to launch your app. Not only that, next to the Run App button will be a drop-down menu that lets you choose how to display your app. So if we go over to RStudio, stop this app. You notice app.r, the clustering app, is saved as app.r, and Shiny recognizes because of that file name, or RStudio recognizes because of that file name that it is a Shiny app. I could click Run App to launch the app. There it is. Go over here, stop the app. Next to Run App is a drop-down menu. If you select Run External, it's going to do what we've seen. It'll launch the Shiny app in your own web browser. But you could also select to launch the app in a pop-up window like this. Or something that I think is particularly cool is to launch the app in a viewer pane. The viewer pane's over here in RStudio. When you launch an app in the viewer pane, it appears right here inside the RStudio IDE, which is nice and organized and concise, and I kind of like it. All right. Now that you could package your app up to share it, I recommend that as you start out, you just use shinyapps.io. Shinyapps.io is a free service run by RStudio that allows you to share your apps online when you want to. You could think of it as a server that RStudio built and maintains for you. It's free to use. It's easy to use. All you have to do is put your app on our server. It's secure and it's scalable. So when multiple people start visiting your app at the same time, the server will wind up extra R processes to handle each person individually, so no one experiences a sort of slowdown in number crunching since multiple people are using the app. To use shinyapps.io, all you have to do is to get your app from your computer to our server, and doing that is very easy. Just visit the website shinyapps.io. This is what it'll look like. So let's come over here to Google Chrome. If you go to shinyapps.io, the web page looks like this. You can sign up for an account right here. Now, I already have an account, so all I need to do is log in. When you do sign up or log in, you'll see that you could create your own shinyapps.io account, or you could just associate with your Google login or your GitHub login. So I use my Google information to log in. So log in. This is what you'll see once you set up your shinyapps.io account. It's a dashboard for your apps and whatnot. But to use your ShinyApps account, you need to associate your RStudio IDE with your specific account on shinyapps.io. And the way you do that is you install a package called ShinyApps. This package isn't on CRAN. You have to get it from GitHub. And if you don't know already, the way to install packages from GitHub is to use the DevTools package with the command install GitHub. And you don't have to memorize all this right now. I'll show you a guide that will step you through this. But what this is going to do is it's going to go to the RStudio GitHub page and install the ShinyApps package from there. I already have it installed, but you can see how it works. Just hit enter. Once you install ShinyApps, the first time you run it, a pop-up window will appear in your RStudio session, and it will tell you to do this. It'll say, basically, hey, I want to know which ShinyApps account you want me to start sending your apps to, so please log into your ShinyApps account, go to your username, and go to tokens. And in the token is a token pair. One of them is secure. You can see the secure one by clicking show, and then you can copy and paste it. And then you'll go back to RStudio and paste the secure token in here. And this is how RStudio will know which ShinyApps account to pair your IDE with. Once you have that set up, every time you run an app, you'll have an option in the top corner to publish the app. If you click publish, it'll say, hey, do you want to publish this app at the shinyapps.io gallery or your account? You could say cancel if you click the button by accident, but if you do want to publish it, then you can just click publish. And it takes a few minutes, but it basically looks at everything your app uses, builds it into a standalone package, and sends it up to shinyapps.io. And when it's done, your app will have its own address. So I'll let this run in the background. I already have plenty of apps here, so I'll show you what you see. For each of your apps that you have on shinyapps.io, you get a dashboard for the app. First thing to notice is the app has its own URL. So this is an app that appears, well, here's our K-means clustering app. It just got loaded and now it has its own URL. Let's look at something a little more interesting. This is an app in the Shiny gallery. Sort of recreates the Hans Rosling sort of Gapminder effect. But here it is. Anyone can visit it by going to gallery.shinyapps.io/Google Charts. They don't need to use RStudio. They only need to have RStudio on their computer. All they need is the web browser, and they can see and use the app. Since I'm the owner of the app over here, I could download the files of the app to my computer. For example, if I'm logging in from a different computer, or if somehow I misplaced the original files. I could look at metrics for the app, see how many people are visiting it, how much memory the app's using as people visit it, and so on. I could tweak the settings of the app, things that make the app run faster, things such as when will the app time out when people start going idle on it. I could decide if the app's going to be public or private. If it's private, then I could add authorized users down here. These people will have to sign in with their Shiny Apps account or their Gmail account or their GitHub account to see the app. I don't want to make this one private because it's public facing, so I'm going to keep it public. I could look at the logs of the app. These are the things that the server gets. Excuse me. These are the things that the server sees as your user uses the app. So as your users navigate through the app, if the R commands that the app fires off, print anything to the server, to the R console, you'll see them here. This is where error messages or warnings would appear. So this will help you understand what your app's doing when it misbehaves. And you can download the log files to your own computer by clicking the button. You could restart your app if you think things have gone wrong. It just needs to be restarted. And you could rebuild your app from source by clicking the rebuild button. And then finally, if you have an app on shinyapps.io that you no longer want to be online, you can archive the app. shinyapps.io will take the app down from its URL. People won't be able to visit it anymore, and the app will just be archived in your account. It's very simple to relaunch the app since it's stored in the archive, but you don't have to do that. If you would like to use shinyapps.io and you'd like something to help you step through those simple but two initial steps, visit this website. It's a guide to getting started with shinyapps.io. It'll step you through everything that I just mentioned and help you start using Shiny Apps to host your own apps. In the beginning, Shiny Apps is free. If you're a small account and you don't consume too many resources, it will always be free. But if you do something like teach a large course that you want to use your Shiny Apps on, so you'll have a lot of people visiting your apps, or you're a consultancy or some sort of business that uses this on a professional level, then you might want to consume more resources. And we have some paid plans that you can use for that sort of activity. Now, shinyapps.io is production ready. It's ready to use in a commercial setting. And these more advanced tiers here help you take advantage of all those resources. But like I said, in the beginning, since we're all just starting out, it is completely free. And depending on what you do with it, it can remain free for the rest of your life. Now, you may not like the idea of hosting your apps on someone else's server, even though that server is our studio server. We promise to be nice and not misbehave, but you have the freedom to create your own server, and we've built a product that can help you do that. It's called Shiny Server, and what it does is it's a backend program that builds a Linux-based web server that's specifically designed to host Shiny apps. Shiny Server is completely free, and it's also open source. So you could download this and use it to set up your own server to host Shiny apps on the internet or maybe on an intranet inside your company. If you want to learn more about Shiny Server, you could do so at the web link there. If you plan to use the server in a commercial setting, we spend a lot of time enhancing Shiny Server with features that would be appealing and create value in the commercial environment. We call this product Shiny Server Pro. It's no longer free, but you can try it out with the 45-day free evaluation trial. What it has that the regular Shiny Server does not have is more secure access features such as LDAP, authentication, Google authorization, and so on. More ways to fine-tune performance, make the apps scale more smoothly. We've invested a lot of time creating ways to monitor and manage resource use in the server, so you get an administrative dashboard, and you can look at each app individually and users and see who's accessing and using what, and to set some constraints there. And then finally, since this is a paid product, we do provide direct priority email support for Shiny Server Pro customers because we reinvest what you pay us to hire a support staff. If this interests you, you can learn about Shiny Server Pro at the same place you learn about Shiny Server at that web link up above. So let's recap the ways to share your apps. The first thing you need to do to share your app is to save it in its own directory with one of the predefined names for your R script. Next, you could host your apps at shinyapps.io by signing up for a free shinyapps.io account or installing the Shiny Apps and then installing the Shiny Apps package. And then finally, you could build your own server to host your own apps at with Shiny Server or Shiny Server Pro. So we're near the end of the webinar, and let's look back at what we've learned. You've learned how to build a complete app with inputs and outputs. You've learned how to arrange things so reactions happen automatically by writing the server function for your app. And you've learned several options for sharing your apps. So now you're ready to go. You have a complete tool belt to use with Shiny. You'll want to put some more tools in that belt as you go along, but you can make basic functioning, useful apps today. If you want to learn more, and I hope that you do, then come back for the next 2 webinars. We'll take a deep look at how Shiny creates reactivity behind the scenes and how you can customize and tweak that process. You'll learn things such as how to delay reactions till your users click a submit button, or how to use buttons and widgets to trigger code on the server side that does more things than just create a plot or a table to put back in your app. The week after that, we'll look at how to customize the appearance of your apps to make them as pretty and as attractive as you like. Since our apps are basically web pages, as you can imagine, we could do a lot with HTML, CSS, and JavaScript. And surprisingly, a lot of that functionality is already embedded into Shiny, which means you can use R to customize your apps. You don't need to know HTML or CSS. In the meantime, if you want to learn more about Shiny, I recommend that you go to the Shiny Development Center. It's at shiny.rstudio.com. There you can find a gallery of Shiny apps with the code that built them. These are all teaching examples that you can learn from and recreate. There's a tutorial that you could take. It's self-paced. And then finally, there's a section of articles that cover advanced Shiny topics in depth. There's about 50 articles there, so there's a lot to learn. All right. So that's the end of today's webinar. And now I think we could take some questions.